Oh, hello and good morning. Well, this is the last Saturday of February, and so that means that we are in for some really good React Native and React action. So, yes, welcome to our regular React and React Native meetup, powered by Geeky Ants and hosted by me, as always, your own Digvijay Wanchoo. Uh, Today's event is a little switched up. We are not doing a very long event this time, but instead of quantity, we are kind of looking into what kind of information we are bringing in for you guys. Of course, that's what we've always been doing. But today's event is not going to be a super long event. Today we're going to have a pretty short one, but obviously we're going to be talking about some fun things, revisiting some really fun things that have happened before, which are of course really important to look at again. And I'm not going to spoil anything for you. Obviously, we're going to let the speakers talk about that. So a quick thank you to all of you for joining in today on this Saturday and sitting with us and having this conversation. To all the viewers who have joined us on the various streaming platforms where we are streaming live right now, um, and to tell you a little bit more about this event and what to expect out of it. Obviously, we have uh, another partner of mine that has been away from this platform for quite some time, but I'm really excited to have him back. Let me take this moment to introduce Neeraj Sinha. I think he's here with it. There he is. Hi,
Hello.
Neeraj.
Hey, good afternoon, Digvijay.
Good
How are you?
afternoon. It has been so long. I still remember you came, the last time you came on a React and React Native meetup was as a speaker wearing that awesome Freddie Mercury t-shirt that you have, which I still haven't able to get, by the way.
Oh, I think
But
that's
but
out of
yeah,
stock.
yeah, I mean, I'll probably just steal it off of you. uh, but it's it's so good to have you back. It's excellent, and you were a speaker then, you are the keynote speaker now, so of course, you moved up, you're now helping me host this event, so that's excellent. I'm so glad that I have you with me here today.
Uh-huh.
Now, how's your day going? How do you feel?
Uh, Usually my day goes around on weekends, going for a match. I haven't also. I woke up late after a long time. Felt good.
That must be
Had
fun.
Yeah, had an early coffee. Uh,
Nice.
Looking forward to listening to our speaker speak about uh, most relevant days in our developer's life.
Surely. I mean, of course, Neeraj has been doing awesome things and building amazing stuff here at Kiki Ants. Uh, I think I spoke about this last time as well, but he is also a great cricketer. And if I'm not mistaken, you're a fast bowler, aren't you?
Yes, but
Yes.
now I'm all rounder and you can see a bat behind.
Oh, wow. Okay. Well, you've moved up. You switched things up. That's great. You should always keep switching things up. Keeps the interest alive. Anyway, Neeraj, so I'm going to leave you to all of our viewers. Tell them what we are in for today, what's in store for them, and what to expect out of this event.
Okay. So, hello everyone. I'm Neeraj. I am a developer at heart and currently working as associate engineering manager at Weekends. And coming back to today's session, we are having some exciting talks coming up. First, we have React Native Accessibility Basics, which is presented by Nivedita Singh, and she's be talking about importance of the accessibility in a React Native application. Also, the guidelines we should follow, the experiment and the experience she gone through when actually implementing accessibilities for her project, and also about the tooling and how to get around with the issues easier. Second of things we have coming up is Retreading React Performance by Akash Joshi. He will be talking about how virtual DOM and DOM are managed by React. Also, using hooks, the standard hooks, the memoization. Also, how does render being affected by state, context, etc. And in the React Native side, Geeky Hands have been doing a lot of things lately. We had a core contributor added to React Native Web, Meenu Mankar. That's a huge shout out to her. You can check out her Twitter profile or LinkedIn profile later. We have a Startup Plus bundle coming up in our native, which is a design system of our own. That bundle contains 100 plus screens, which contains almost 80% of everyday project you will see, everyday website you will see, or an app, which contains auth, navigation, sign out, and terms and condition, all of those things, etc. We have Builder X, which is a coding tool which generates React and React Native code, which is production ready right from the word go, and with some training in ideal situations, a developer should be able to a designer should be able to generate production ready code pretty easily. We have FormST, which is a new package we have come through. That's a model based form package. And if you are a fan of Mobex and Mobex state tree, you will just like the FormST. Do give it a try. And we have React Native 0.67 released just a month ago. It's not a major upgrade, but you can go and have a look through. And we are closer to have Hermes as a default JavaScript engine for React Native. And regarding today's meeting, I mean today's session, we hope to hear from you. We hope we have a lot of questions and we have a lot of discussions going around. But we also hope that we have some code of conduct being followed by each and every one of you. That include not having to use hate speech or inappropriate comment. Keep it very light. Be respectful and refrain from any strong words. Don't spam questions. If you have posted a question, please wait for our speakers or anyone to take them. If you have another question, please put it through. Well, but please refrain from spamming. And this is a space for growth and learning. Promote that. Get to know your fellow attendees and speaker, and do network among yourselves. Thank you. That will be it from me. Let's hear from Digvijay once again. Thank you.
You call me, and here I am. Thank you so much for that, Neeraj. A couple of things that, of course, Neeraj has already briefed you all about the event today and what to expect out of it, what our speakers are going to talk about, and of course, big shout out to Meenu for achieving what she has. I mean, do go check her Twitter and GitHub out. It's amazing. That's Meenu Makkar. Uh, big, huge shout outs to her. Also, of course, we've Neeraj has taken the time to talk about so many things that we are doing in the React and React Native space. I mean, there's BuilderX, there's the new native phase 3.0, there's the startup bundle that's coming out that's going to cut down production time by almost 50% for all of you folks out there. So go check that out. Uh, and of course, Neeraj also talked about this little code of conduct that we have to follow. Just to reiterate, if you have any kind of questions, they're more than welcome. Please leave them in the live chat, and we would get those answered by the speakers for you. Try not to spam them because we just have a record of everything, so we'll eventually get to you, and we will not let your answer questions go unanswered. Uh, and Neeraj, I think it's time we begin with the show and
Yes.
get our first speaker going. So thank you so much for handling the keynote so well. I think you've just given everybody enough to get them hyped for what's to come.
Yep.
And I will see you towards the end of the event again.
Thank you.
Thanks, Neeraj. All right, guys. I think it's time for us to bring forward our first speaker of the day. It is my pleasure to introduce you guys to Nivedita Singh, who is a mobile engineer intern at Small Case. But being just an intern, she's doing so many things. Is Nivedita here with us?
Yeah. Hi everyone.
There she is. Hi, Nivedita. Very good afternoon. How are you doing today?
I'm doing well, thank you. Thank you for letting me here.
Of course. It's our pleasure to have you here and speak with all of our viewers. Uh, I saw that you are currently pursuing your MCA at JNU, and you are focusing. I mean, I think your focus is more towards OOPS and all those data structures and all of that. If correct me if I'm wrong, But what really caught my eye, apart from you being a mobile engineer intern, is that you're doing a lot of social work as well, which I would like to know more about. So, would you mind telling me?
So yeah, when I was in my undergrad, I was a part of this society called the Social Service League, and there I used to teach, like take evening classes for students of the underprivileged, and
Oh,
like the children of the like non-teaching workers of our college.
right,
And I was also a part of the executive council that would organize events for the disabled people of Delhi
right,
University.
right. Well, guys, I think there's already so much to learn from Nivedita, but I think there is a lot more that she has to share. So, Nivedita, I'm going to leave you with our viewers now, and all the best.
Okay, thank you. So, hello everyone. I hope my screen is visible. I am Nivedita Singh, a mobile engineer intern at Smallcase. I work on the cross-platform app and the website. And then today I'm going to share what I've learned about accessibility and its implementation in the past few months. So let's start with what are we going to discuss today. This talk will be about the basics of accessibility. Why should we even care about accessibility? Some guidelines that were set up to ensure that this is implemented well, and how Android and iOS natively allow developers to make accessible apps, and the features provided by React Native for the same. Certain problems that I face, that we as a team faced in implementing Ally for mobile apps, and then we'll have a brief discussion on Ally tool. So let's get started. What's the whole buzz about? What is Ally? So Ally is accessibility, how usable a website, app, or other digital experience is by all possible users, regardless of their ability or disability. Why should you care about making your apps accessible, apps or websites? Because over a billion people in the world are disabled and they have a higher chance of being unemployed. And every one of us is likely to be disabled in some form at some point in our lives. And some countries like the USA, Canada, they require you to make accessible websites and apps by their law. This is only for Indian government websites here, but I hope we have some improvement in this field. Also, right. So when we think about disability, I think the first thing that comes to our mind is how is about people who cannot see. But there are several types of disabilities. First, of course, people who are visually impaired. This disability can range from blindness, low level vision, to color blindness. Such people use screen magnifiers and use the zoom capabilities of their screen readers. Then, hearing impairments. Such people are deaf and hard of hearing. This can range from various levels of loss, ranging from mild to profound. When we have people with mobility impairments, they can have disabilities concerning movement. So their impairment can be triggered from some physical problems or neurological disorders, because of which they cannot move their hands or feet. And then we have people with cognitive impairments, people with intellectual disabilities, or plain simple old age. They will have difficulty thinking and remembering. So let's start with an example of how inaccessible certain things in our world are and what we as developers can do to fix it. So we all know about Wordle, which is a popular word game where you have to guess a 5-letter word and then you get some clues along the way. It'll help you nudge you towards the right answer. Uh, some of us have played Wordle and enthusiastically share the results on our social media, like on our Twitter feeds. Like we can see it continuously. Now it gets annoying sometimes, but it gets really annoying for those people who need screen readers to go through their Twitter feed because it's inaccessible for them and they cannot choose to look away. Their screen reader, like it gets difficult for them to stop their screen reader from reading out whatever is happening. I'm going to share a clip of how a screen reader reads out worded results on Twitter. They read out a long, indecipherable list of green square, yellow square, white square, which is inaccessible and confusing. I hope you can
Comma.
hear.
3 green square. White large square. White large square. New line. 3 green square. White large square. White large square. New line. 3 green square. White large square. Yellow square. New line. 5 green square. This is my latest Wordle. A grid of colored squares representing letters, which is 5 across and 4 down. The first and second rows both show 3 green and 2 gray squares. The green represents a letter that's in the word and in the right place. Gray represents a letter that's not in the word. The third row shows 3 green squares, 1 gray square and 1 yellow square. The yellow represents a letter that's in the word but in the wrong place. The fourth row shows 5 green squares, which means all the letters are in the right place to make up the word.
So the second half of the video was about someone who cared. They made a tool which allows us to take a screenshot of the emojis or the emojis in the worded result, and then they turned it into a descriptive alternative text of what was happening. The second part of the video was informative to everyone, even if people who don't know anything about Wordle. It provided a context and it was generally accessible to people who require screen readers. So we might be discriminating against people who require assistive technology if our app doesn't work for them. Like we're not doing something special if our apps are accessible. It's like deliberately using a certain color, let's say yellow, throughout our app, when we know that a certain significant portion of our users cannot see the color yellow, perceive anything about related to it, and the app will be of no use to them. Something called the social model of disability says that people are disabled by barriers of society, not by their impairments. And removing these barriers creates equality and offers disabled people independence. So someone who's on a wheelchair and requires a ramp to go to a building is not disabled because they need it. They're disabled because society, that particular building does not provide a ramp for them to access that particular place. So now that we know that we should make our apps accessible, how do we go about it? Are there any rules that determine the right way to do things, or we can just generally cook up ways to make it work ourselves? No. So there is something called the Web Content Accessibility Guidelines, WACG, which were developed through the World Wide Web Consortium called W3C, too many acronyms, in cooperation with individuals and organizations. These guidelines provide a single shared standard for web content accessibility that meets the needs of people. They are organized under 4 principles. Major things that web and app content must be in order to be considered accessible. For each guideline, there are testable success criteria at 3 levels: A, AA, AAA, where each is progressively stricter. So let's say a website is following level A. Then that particular website won't differentiate between a positive signal and a negative signal by color alone. Like for example, it will have some text. It won't just have a red button and a green button. Level AA would mean the text color meets contrast requirements. The ratio between the text color and the background color is of a particular value. And level AAA would mean a very dark color or a very light background, a very high contrast requirement, which is difficult to meet. So websites usually go for level AA. So let's start with the first guideline of one of the 4 guidelines, being perceivable. Small screen sizes limit the information people can view at a time when they need magnification to view it. So let's start with providing a reasonable default size for content, so that they don't have to keep on, so people using screen readers don't have to keep on zooming in and out to view content. We can position form fields below their labels so that people using screen readers don't have to uh, scroll horizontally for accessing content. The success criterion related to zoom magnification is that text should be resizable without assistive tech up to 200%, by up to 200%. And the level AA contrast requirement is 4.5:1 or 3:1 for large scale text. The second would be operability. Your content users must be able to control UI elements through mice, keyboards, or voice commands. If they're not able to use a touch features, touch targets should be at least 9 millimeters, like buttons and icon buttons, and there should be some inactive space around. This will also help people who have fat fingers. Touchscreen gestures in apps should be as easy and predictable to carry out, and touch end events should be triggered like only when the user removes their fingers from that particular element, and there should be some on-screen indicator that remind how and when to use that particular feature. On the Gmail app, we have a feature where we can swipe right on a particular element to archive it. So if you're implementing something like this, we should give an indicator about it. And then device manipulation gestures, things that are triggered by shaking the device should, like, they're fine, but they're not accessible to people who cannot like move. So for them, there should be some alternative control options, keyboard touch control options. And buttons should be placed in such a way that they're easily accessible to people who are both like left-handed or right-handed and cannot move their devices too much. Because let's say the device is attached to their wheelchair. The third guideline would be content should be understandable and it should support both orientations. So because, yeah, the same reason as the last time, sometimes the devices are attached to the wheelchairs. The navigation of content should be consistent, and they should appear in the same order in every screen as much as possible. And any components that have the same functionality should be identified consistently. Like they should have the same text. And we should provide some clear indication that elements are actionable. And we should provide tooltips and tutorials for custom touchscreen and device manipulation gestures. The last guideline being the content should be developed using well-adopted web standards that will work across different platforms now and in the future. One of them being, we should set the virtual keyboard to the type of data entry required. If you want the user to input numbers, allow them to only input numbers using a numpad, don't confuse them. And text entry can be confusing for some people, like it can be a long drawn process. So you can shorten it up by using radio buttons, checkboxes, and automatically find out the user's date or time, etc. And support the characteristic properties of the platform, allow zoom, larger fonts, captions. And most platforms have the ability to set large font size, but they do not wrap the text, causing a lot of horizontal scrolling. Now that we have come to the next part, I don't think there are any questions, so I'll just go to the next part. So, Ally for mobile apps. So, how do we implement accessibility on mobile apps using platforms like Android, iOS, and React Native? So, the intention would be to design well-defined, clear task flows with minimal navigation steps, especially for major user tasks, and then label the UI components and make sure users can navigate your screen layouts using keyboards, mice properly. So this is a brief description of how accessibility can be implemented on Android platforms natively. We start with describing each UI element by using the content description XML layout attribute. Then we can make the parent element focusable by setting screen reader focusable for true. This will ensure that when the screen reader is reading out a card with several texts, with a lot of text in it, the user doesn't have to separately focus on each element for the screen reader to read it out. All of the text will be collected together and read out by the screen reader. And then for edit text, where users can input information, the labels that we use for them can have something called label for. This will help the accessibility services. Similarly, for iOS, we have UI accessibility, which is a set of methods provided to the NS object. The NS object is a root class of most Objective-C class hierarchies, from which subclasses inherit a basic interface to the runtime system. Now, all these methods like UI accessibility container, UI accessibility action, focus, and dragging, they provide certain services like the first one provides information about views and controls in the app's UI. The second one makes subcomponents accessible as separate elements. The third one would be supporting specific actions. And the fourth would be whether an assistive app such as VoiceOver has focus on a particular element, this would return booleans. And the last one would be a pair of properties that allow you to fine tune how drag and drop is implemented. So now we're going to talk, I'm going to talk about React Native accessibility APIs. Both Android and iOS provide APIs for integrating apps with assistive technologies, like we just saw. RN has complementary APIs that let your app accommodate all users. That's your app. So we have accessibility properties like accessible. When this is true, this is similar to when we set the screen reader focusable on Android. This indicates that the view, that all the children of this particular view will be clubbed together and read out in a single go by the screen reader, instead of user having to individually focus on each element. We'll talk about this in a bit. Accessibility role. It communicates the purpose of the component. It can be either a button, a link. We can also have heading as the accessibility role, which will be helpful for a user when they are navigating through the different pages of the app. This will help them know what is there in a particular page so that they can quickly skip it if it's not interesting for them. We also have something called accessible label. In this particular case, we don't need a label because we have something called submit code. This is a button with a roll button, and state, we'll come to that later, something called submit code. This is the text of the particular button. Let's say this was, so we know that after we click on this particular button, it's going to submit code. But let's say it didn't have a text here, but an icon of, let's say a refresh icon. Screen reader wouldn't know what's happening here. Then we would need to add an accessible label here to tell him that this is a refresh. This refreshes everything. Right. There's something that's called accessibility state, which denotes the current state of a component. We have a disable button, we can just set it through here. Then we can have selected or expanded states. Lastly, we have something called accessibility hint. This is for situations where, let's say, clicking on a certain button is going to open the mobile browser from the app. It's not going to open a new view. We would then like to inform the user beforehand about the effects of this particular interactive element. These are the other properties available from React Native. A few of them are only specific to one platform. Like example, accessibility live region is a good way to make announcements specific to Android. What happens here is, let's say you have a particular view on the top of your app where you make announcements, and you're currently focused on some other view. there's a change to that particular view, you will be automatically informed about it by your screen reader. There are two types, like polite or assertive. Polite would mean your screen reader won't interrupt your whatever is going through right now and then come back to that announcement later. Are there any? Okay, I don't think there are any questions, so I'll just continue. So I'll start with some examples of ally problems that I faced, that we as a team faced while starting on a journey of making our app accessible. So a major problem is making images accessible. The screen reader can easily read out the text, but what happens when we have to convey some important information using images? Let's say you have a carousel which belongs to a particular class of elements. In this case, small case specials. Screen reader won't be able to read out the text in the image because it's a part of the image. So there should be some accessibility label assigned to this particular image to tell the screen reader what this particular carousel is about. Similarly, you can have icons as buttons. Screen reader will read out funds in 10 crore. It won't tell you that a buy button exists there unless you point out that it has a role and a label. Now I will talk about this particular issue where this is an example of a small case, but we can take a general example of a particular item with a few properties like, let's say, name, label, description, minimum amount, tagger, and an icon for watch listing, for keeping a track of how it progresses. The card itself is clickable. It'll lead us to a page where we get more information about this particular entity. And we also want the watch list icon to be clickable. Now, if we assign a label to the button and ask the screen reader to go through it, this is what it's going to read. This particular line, hello, blah, blah, blah. And in the end, it's going to read tap to watch list. This is wrong information because tapping on this card is going to lead us to the profile and not going to watch list this element. Why is this happening? This is happening because of some rule that was breaking here, that we cannot have interactive controls having focusable descendants. If the card itself is interactive, its child should not be focusable. Hence, accessible is true here by default because this is a touchable element. As a result, all elements are gathered together, read out, and the icon cannot be individually focused. So the way to fix this, because we want a screen reader users to watch list it, is to either set accessible false here, so that we can individually focus on the elements, or to only make the header clickable, which is the better solution here. The next problem would be, let's say the screen reader has to read this out, information in 2 columns. How the screen reader is going to read it is by saying stats when equipped, slot head efficiency, armor 5, protection minus 30%. It's going to mess up the whole thing for someone who cannot look at the screen. They will have no clue what's going on. The problem here is with accessibility focus order in React Native. On the web, determine the flow in which things are read by looking at the DOM tree and going from top to bottom. We have no such structure on mobile apps. We don't have semantic XML here. So iOS natively reads elements from left to right, top to bottom, which is not appropriate for our case. So right now, React Native has no official solution to it, but a workaround could be that we would create a wrapper that adjusts its behavior according to the native platform it's working on, and then it will group all subviews together for accessibility purposes. This was about implementations. I think I don't think there are any questions till now, so I just continue. So allied tooling, what is that? We're going to talk briefly about tools that we can use to test our content as developers, whether our apps are actually accessible to users. So we can start with iOS. For simulators, we have something called the accessibility inspector, which we can use the crosshair icon here, this one, and then tap on the element, sorry, hover on elements to find out their accessibility properties. And we can also use voiceover with the simulator. Voiceover is a screen reader for the Apple platform, and we can use it for the simulator by clicking on the control resorption command, which is called VO, since it's always used together on Mac. And then space key to click on items. If we have a physical device, we can use voiceover, and we have the following gestures. As a screen reader, how exactly a user would use it. Next, for Android, we have something called accessibility scanner. This is not for the simulator. We can also use it for the physical device. It is an app which can record workflows or take screenshots of screens and then audit them for accessibility issues like your app screens. And like it can check whether your content has labels, whether the touch target size is large enough, whether the items are clickable, or there's some contrast in the text. And then it can propose solutions. Like, for example, this is the homepage of the small case app, and we run accessibility scanner on it. We get a few suggestions. Like, let's say we have here the help icon is not accessible at all, even the account screen. This card itself. If we tap on this watch list icon, we can see more information here that this item may not have a label and the touch target size could be larger. Here are a few talkback gestures. What is talkback? It is a screen reader used for Android apps. Uh, Scanners can be used for tools, but they cannot replace a human testing your app for accessibility. Accessibility needs to be approached holistically because tools cannot convey whether your UI conveys semantic information simply and clearly. It cannot report whether it can tell you that the certain element is missing a label, but it can't tell you whether the element you've added makes any sense or not. And it cannot report on how well an app supports multiple modes of interaction, like touch or voice. So we cannot just rely on tooling. We need manual testing, like to test our apps for being accessible. Here are a few links that I had referred to while working on this topic. Thank you. Please add in if you have any questions.
Hi again, Nivedita.
Hey.
Uh, I think there are some. Oh, there you are. Okay, now I can see you. Well, thank you for that. That was a very insightful presentation on how accessibility actually works and how it should be perceived. I actually particularly liked the context that you set, and I mean, it was a fresh view at why accessibility is important and why it should be a priority when developing apps. Uh, which was great. So thank you for that. Uh, for the time being, while your presentation was going on, we don't necessarily have any questions from the speakers at the moment. There is one question that did come in from Omi Power, but that I think is a more generalized question. So I think I'll probably put that towards the end of the event. Uh, so thank you, Nivedita. Thank you so much for spending
Thank
your
you.
time with us today. And of course, I'll see you again towards the end of the event. So see you then.
Thank you. Yeah.
All right, folks. So that was Nivedita, and she talked about accessibility and why it's important and how you can look into accessibility in React and React Native. Uh, I think the context that she put together for accessibility was amazing, and it's probably something that we need to look into. We should look into. But for now, let's move on to the next and the last speaker of the day. It's my pleasure to introduce you guys to Akash Joshi, who is going to be talking about React performance and going back and looking at how it has evolved today. Akash is here with us. Hi, Akash. I think you have some internet issues, maybe. I'm not able to hear you as well. Are you saying something? I really cannot hear you. Oh, wait, heard something.
Okay, yeah, I switched my microphone. I think
Yes,
now you.
now I can hear you. Perfect. How are you doing today, Akash?
Yeah, I'm doing well. I'm doing well.
Great, wonderful. So, Akash, I'll leave you with our viewers. We have a lot to cover, and I think you're the best person to take that forward. So, I'll leave you with our viewers, and all the best.
Thank you, thank you. All right. Hello, everyone. Firstly, I would like to say thanks to, I guess, Nivedita for warming up the audience with her amazing talk on mobile accessibility. I worked with accessibility on the web, and it was my first foray or view into how accessibility works on native devices. So it was nice to learn more about that. And yeah, my name is Akash Joshi. You can find me as the writing dev on most social media platforms. And today we are going to be talking about revisiting React rendering. So I renamed my talk to revisiting React rendering because I don't feel as comfortable talking about the performance side of React. But I've done some research recently around how React rendering happens and how things work internally, just to be better at my job and to help with my side projects and stuff like that. About what I do, I am a platform engineer at Hash. Basically, if you go to hash.ai, this is what we do. And if you check out our careers page, and if you are looking for a new senior role right now, be sure to check the "We are hiring" tab right over here. So, anyways, back to the talk. Back to the talk. Yeah, as I said, I've been recently experimenting and trying to find information online about how React rendering works and what actually happens inside of React. So, and yeah, about the difficulty of this talk, it is going to be very straightforward, and I've tried to keep it as beginner friendly as possible. So, advanced folks, feel free to correct my mistakes wherever you can, because that will help me be better at my work as well. So, yeah, the first step is about React rendering itself. How does rendering happen? Well, firstly, you write your code in JSX, as you all know, which is basically an XML-like syntax in which you can pass objects and functions inside of the attributes, so that any uh, child tags. I guess we use the parent-child terminology in React, so you know what I'm talking about. But any child components can use the references from its parents, and basically we are calling them props inside of React. So yeah, I've got an example like component on screen right now. So I mean, most of you might be familiar with something like this. This is a counter component, and I have defined a child component here, which takes up count prop from its parent, and the parent also has a button which modifies the state as needed. So for now, we won't get into the depths of it. We had a look at what JSX looks like, and then this JSX is converted into bundled React code, which is basically create element function calls and other things like that via build tools like Webpack, and then Webpack plugins like Babel. So for example, we can input the code that we just wrote over here. And once we do that on the right hand side, what is this? This is the Babel playground. You can try putting in any of your JSX files in here to see what the end product looks like. So this is the actual code that your browser sees, and based on the functions present here, function calls are made to the React library, and based on that, then React generates your virtual DOM. So virtual DOM is basically a representation of the JSX that you have provided, and why React holds a virtual DOM is to avoid making changes to the real DOM as much as possible, because changes to the real DOM are expensive, since it results in a paint on screen, which is a hardware intensive process. So yeah, we have a virtual DOM, which we'll have a look at soon, and then the real DOM is generated from it. And these two phases are independent from each other. So the first phase where the virtual DOM is generated is called the render phase, and we generally have more renders than commits. The commit phase is basically when React goes through the virtual DOM tree, and for each render, you will have a new representation of what the UI should look like via the elements that you are providing to it, since React is a declarative language. And internally, React decides which DOM nodes it needs to update through a process known as reconciliation. And then it finally goes and updates it in the actual commit phase. So generally, you have more renders than commits, and we are going to go into an example of that. So yeah, let's have a look again at the previous code example that I had shown. Again, to reiterate, we have a state for a count, and then we have a button which increases the count, and then a counter component which is just responsible for displaying this for now. So why have I created this? Let's go into the page and just have a look at the actual component ones. So yeah, so the wait, what did I do just now? Yeah. So the important bit here is basically this one. I am creating, instead of directly writing the JSX in the return part of the function, I am defining it as an element, and then I'm console logging this element just so that we can see how the virtual DOM is being represented inside of React. And you can do this with any component that you have. Just console log the JSX that you're returning instead of directly returning, and then you can see what it looks like. So, all right, here I have the actual, yeah, I've opened the console and I can see what the elements internally look like. So this is on first render, so I guess Chrome doesn't really know what to do with it, but I'll increment this once, and every time I click on increment, the counter here increases its number based on the internal state in React, and then a new element is also generated in the render phase. So again, we talked about render phase and commit phase. So this is uh, whenever a render occurs, the console log part of the code is running, because it is trying to parse this component and trying to generate a new virtual DOM from it. And then the commit phase is the phase when the actual UI gets updated. So for each render phase, we are getting a representation of the virtual DOM object for the counter that we have console logged. And here we can see all of the properties that are present on the React element. If you look at the TypeScript type for it, you'll see something similar as well. So type of, which is basically React element, and then the key, we aren't passing any key here right now, and we'll have a look at what the key attribute really means. And then props, inside of this, the props being passed are basically the children. As you know that these, I mean, anything that you define inside of your JSX automatically becomes part of the children property, and you can access it generally via props.children. So this is what is being passed down here. And then other properties like ref and type, which you might already be aware of. So ref is kind of like the reference to the DOM node. I guess we can go into that a little bit as well. And then type is basically what type of DOM node is being generated. So in this case, since this is a dev node, the type that create React element, React.create element is generating is dev. And yeah, as we said that, I mean, what we saw here was basically the render phase and commit phase being the same in amount. But let's see an example where there can be more renders than commits. So for that, firstly, let's inspect element this and try to see what a commit looks like. So Chrome and Firefox and other web inspectors are really helpful in that whenever you make a DOM change, they helpfully highlight the change that has been made. So if you just click on increment a bunch of times, you'll see that this number is being incremented. So Chrome is helpful for that right now. And to show an example of renders being made, but the commits not being made to the UI, I can just remove the count from element, like the count, I guess variable, we can say for now. And then what we see is that whenever I click on counter, that doesn't really cause any commits because there is no UI change to be made. React already knows that, so it won't make any commits. But internally, it is still creating new renders, new versions of the virtual DOM for each state change that we are creating. And to test that, we can just click on increment a bunch of times, and then the console log that we have written in our child component, it gets updated. So this is a pretty good example of how the React phase and the commit phase work. And then, I mean, in your app, you can also try this out and see how things might be functioning internally. So yeah, that was about React rendering. Next up, we have optimizing lists. Now, this is somewhat interesting because I think this and the next slide are good. I mean, a good reiteration for some of the more advanced folks, and for the juniors, like they might be learning something new from this part as well. So if we go to a React element, we saw the key prop here, and yeah, I guess you might be curious, what does it actually do? Key is basically a way for developers to help React uniquely identify each DOM node. So mostly React tries to implicitly make changes and updates to the DOM nodes on screen. But sometimes for things like arrays, where you have an internal description of what the array looks like in a state variable somewhere, and the DOM nodes might not exactly map to what that array state looks like, it is helpful to pass in the key variable so React can identify each of the internal state of the DOM nodes with the actual DOM nodes on screen. And to test this out, what we are going to do right now is write an array from scratch, and I mean basically like try to render an array from scratch, and based on that, we'll see how React kind of breaks down when we pass down the wrong key or an unstable key, and what we can do to fix that. So yeah, hopefully I didn't hype that much, write up too much, because it's a really simple test that you can try it out yourself. So yeah, I'm using Next.js here, so I have to make a default export at the top. So I'll just write something out right now. Firstly, let's just say I write out something like array test, and let's check if that gets rendered on screen right now. So yep, we have this getting rendered. Now we'll go into writing our actual array code and see what happens. So I'll define an array here and have an initial state generator for it. So just a second. I'm on Windows right now, so the auto import system isn't that great. Yeah, use state. Yep, thank you. And so yeah, we need to render something on screen with the array that we have. So we need some data for that. I'll write a very simple function, get array, which will generate an array, and then generate an array, let's say of size 5, and then returns random elements inside of it. So it will do something like, I guess, math.random star 100. So we'll get elements from 0 to 100, and then I'll add dot to fixed 0 to make this uh, to remove the decimal points from it, and then we can check the return type of to fixed, which is string. We need numbers here. I mean, we don't really need numbers, but since these are like numbers which we are generating, it would be helpful to have the correct return type on it. So I'll just use parseInt on this to convert this into integers. And now, let's say we generate, okay, I might have accidentally clicked on something else, but yeah. Yeah, as an initial state, it will generate the array from get array, and then let's say we just print that on screen for now. So array.map element, and I need to display something with the internal state of the actual element as well. So I'll create a new function, I mean a new component for the individual elements, which I'll describe here. And then for now, let's just say that we are passing in some data as element here and displaying it right over here. So yeah, this will do that. So now looks straightforward till now. We have a function which generates arrays for us. We have an array state in here, and we have a simple component which just displays whatever element we are passing to it. So I'll call this component here now, element, and element equals to element. Okay, too many elements in here, but I guess that's okay. And then ESLint, of course, complains to us that we need to pass in the key property to an array. And this is the unstable version. So for now, I'll be passing the index of the array. I don't recommend doing that for reasons we'll soon be coming to. And now if I save it, okay, so I'm getting nan. This is always interesting, debugging problems while giving the talk. So okay, it's still throwing nan. All right, no worries, we can solve this. Dot fill new array 5 dot fill dot map. Is there something that I've done wrong here? I'm sure there's a pretty okay, yeah. Wait, I do have I always create separate pages for the actual, I mean, what the final thing should look like, because things like these end up happening. So no worries about that. I'll just pick that function from here and then paste it in here. And yeah, all right. Okay, let's just ignore the last 2-3 minutes right now. And yeah, so we are generating a random array and then displaying it here. So let's say that we are trying to add more elements more elements to this array. But since we are trying to display a non-regular example, irregular example, let's add elements at the start of the array instead of at the end of it. So I'll add a simple like button, let's say add elements, and this will add elements at the end. So on click, I will do something like set array and generate a new array and then spread over it. So generate random array, spread over it, and then spread over the existing array that we have. So this should add elements to the top of the array that we are seeing. So now when I click on add elements, okay, it's still generating new elements. It looks fine, right? But don't worry, we'll break this soon. Now, instead of passing the element down directly, let's say that I have an internal state, something like, again, the good old counter example. Let's say I am displaying an array of counters instead of, just displaying using the elements directly. I'll pick up count from here, paste it in here, and now I save this. And yeah, this looks fine for now, but once I refresh this, all right, Next is taking its good time. Okay, so now if I click on add elements, whoa, what happened there? The same array got duplicated. I mean, the array that we saw at the first time, it got duplicated because React doesn't know which state to pass to which array element, because we have an internal state that we are defining here, and then we are mapping over it to the actual components. But which array element maps to which component? We are passing the wrong, an unstable key here. So React doesn't know how to identify that. And yeah, if we keep on clicking on add elements, it just duplicates the same array instead of actually displaying the correct elements. So one way to fix it, I mean, the right way to fix it is to pass unique keys. And let's say that for now, since we are, generating random elements anyways, we pass that in. And if we do that, does that fix it? So, all right. So looks like that fixed it. So yeah, this is a very good example of why you should be passing in unique keys to your elements. Now, if I click on add element here, we can see that all of the elements are being generated correctly. So yeah, I guess I'll just leave it at that for now. And if anyone has any questions or any complaints about this, please do add them at the end. So next up, let's look at remounting components. Another good use case for using keys is basically remounting any existing components that you might have. And this is something which unfortunately I didn't know at the start of my career. So I was writing, I was like handwriting code for resetting forms and things like that. So for now, let's just reuse the existing component that we have on screen. But for now, I'll just remove the array and replace it with a form. So, all right, we are displaying this, so we can remove that. Let's say that we have a form component, which is rendering a form on screen for us. And it's like a pretty complex form, which has, let's say, a text input. Then we are taking, let's say, the user's phone number. So we have input type equal to tally here. And then let's say we also are taking, we are asking them to sign off on the terms and conditions. So we have a checkbox here. And then finally, the user can go and submit this form. So submit on here. And then to prevent any refreshes, I'll just add a good old event.prevent default in here. And yeah, let's try rendering that form in here now. So we'll replace this to form test. Wait. Yeah. So yeah, we have this form. We don't need this button as well. I'll just remove the on-click element from this and add reset form in here, and we'll see how this works. So I have some elements which I'm input elements which I'm adding data to, and on clicking submit, I will have to manually write the code which resets the internal state. Or the easier way, which all of you already know of, is like you can remount the component. But instead of using something like conditionally rendering two versions of the component or doing something crazy like that, there is a very simple way of causing components to remount. The senior folks already know what I'm going to be talking about, and that is basically using key again. So when you pass in a new key to a virtual DOM node or a React component, then React will think, we are basically telling React that that is a new component and that you should unmount the old component and then remount the new one. So I guess we can call this count or key ID or whatever you want to. I'll just call this count for now. And then on click on the reset button, I'll simply increment the count that we have. Cool, nice. So yeah, we are rendering this, and if I enter something here, I'm still not doing anything on submit, but let's ignore that part for now. And let's just focus on reset form. So when I click on reset form, magic, all of that data is vanished. And that's because the key for that component changed. And if you are not yet convinced that the old component is unmounted and new one gets remounted, let's have a look at use effect and try console logging something to the page. So on whenever use effect runs in for the first time, let's say that I run mount, and whenever the cleanup function is run, I run unmount. And okay, cleanup is not defined. Yep, I need to update my keyboard shortcuts, I guess. So yeah, we have this on screen. And am I on the right page? Yeah, I'm on the right page. So if I refresh this, then this component mounts for the first time. And if I make any changes here, submit, nothing. And when I click on reset, then the old component gets unmounted and then the new component mounts in. So that's what causes the state refresh that we are seeing here. And yeah, that brings me to the end of this slide. I think we have virtualized lists, which is another good way of reducing the number of commits that you might be causing. So virtualized list is basically a list in which instead of rendering all of the virtual DOM nodes as DOM nodes, what you're doing is you are rendering a subset of the DOM nodes. I mean, a subset of the array elements that you have on screen. And I mean, this is done based on where the current user is. So you use something called the intersection observer, which helps you in doing that. And then you add padding to both sides of your parent container to simulate an infinitely scrolling list. So yeah, virtualized components. I mean virtualized lists. Sorry, I suggest doing more research on that. I won't get into more detail about that because it's a talk title on its own. And yeah, so that was mostly about the commit phase of React rendering. And now let's focus a little bit on the render side. So yeah, nowadays we all use useState and useEffect, and why they exist. A boring answer for that is because functional components exist and they need to be more powerful. But a more interesting answer is that class components were really, I mean, the way we were doing things in class components wasn't really that great. And we'll go into more details of why that is. So firstly, I guess this won't make a lot of sense if you haven't looked at class components before, but you know that classes have constructors. So I guess that helps you in classes have constructors and then functions that you decide inside of it. So class components in React use those to basically take input from the user and then generate a VDOM and then the DOM node and all of that good stuff. So how we handled state initially was we had this dot state, I mean a state variable defined inside of the class, and then whenever we ran the constructor, that is when initialization was done. So basically this dot state is equal to some state. And another thing that you might notice is that instead of having multiple state variables like we can define in functional components via the use state hook, here we only have one state, and then that state is a combination of all the state that your component holds. So it can become very complex very quickly. So here we just have a counter, but imagine you are storing user IDs, then user details and all of that inside of this component. So it can become very complex. And on top of that, we just had one set state function. So all of this is in the React docs. I guess I don't really have to go into the depths of it, but basically set state works kind of like the same like our current set state function. You pass an updater to it, and then it has a callback for stuff that you can do whenever set state runs. So yeah, that's how state used to work. Now going into effects, by effects I basically mean network calls or any GraphQL subscriptions or WebSocket subscriptions or anything which you are trying to do outside of the context of your React app, how it used to happen in the olden times, pre 2018 I guess. So yeah, we have a few life cycle functions here, and basically what these did was like I think the two most important ones for us right now are component did mount and component did update. So component did mount, it executes when the React component gets mounted onto the DOM, and component did update, it ran whenever either the props changed or the state changes. And I might be wrong here because I haven't worked extensively with class components, so feel free to correct me. So that's how it generally worked. And in component dot, so where API calls and other effects happened was generally in component dot update. In this case, like this is from the official doc. So the recommendation generally is that you check for the props, and if the value of the props changes, or I mean the value of the state might change, then make the function call. So this might look, I mean, if you worked with use effect, this might look kind of similar to that, but you kind of see what the downside here is. This is creating an implicit dependency between props or state and some effects or function calls inside of your code. And implicit dependencies are bad because they make the code more difficult to read for newcomers. And on top of that, it is also more difficult for parsers like let's say ESLint to know what's happening inside of your component. So just for that reason, like use state and use effect are a big you know step up from how things used to be done, because you know that if you have I mean, I'll just define a dummy component here, why not? So let's say we have something like display user data or something, and then that component takes in the state of user ID. And let's say that, you know, we are just displaying something like, I guess, user time here. So you know that if you define a use effect and subscribe it to the user ID by adding user ID to the dependency, then you can reliably, okay, what does that do? Yeah, so you can reliably make function calls or any effects from inside this use effect. And you know, like, I don't know, I'll just pass in the user ID for some reason. So yeah, you know that any uh, any code or effect that you have defined inside of use effect, it will only run when its dependency array changes. So this is more explicit, I mean, which makes it more readable both for machines and for humans. So there's something you can use on top of that to help in the readability and the debuggability a little more, which is basically like rules of hooks. You might have heard of it, but this is just a suggestion that I'm making in case you don't already know about it. So yeah, rules of hooks. There are some rules which exist, but you can use an ESLint plugin to help you in, I guess, doing it automatically for you, or at least pointing out whenever you are doing things wrong. And yeah, I guess we'll quickly go through this, but basically reducing state renders. We'll see how rendering in functional components happen and how you can kind of optimize state renders here. So I have defined an example component for this already because I know that it might, I mean, it might be a little later in the talk that when this part comes up. So I'll try to go here, state cascade. So yeah, basically I've defined kind of like a tree of various React DOM nodes. This is the generic counter example again, but it's helpful for doing that because I mean, we are already familiar with the example and it quickly, I mean, there's no need to understand new code. It's all old code and we can get to the meat of the problem. So right now we are trying to debug how React renders occur, kind of like the first piece of code that we were looking at. So I have the top level page component here, which has a button defined, an internal state, and then the first child component. So I am passing the value of count from the parent to the first child. And then what the first child is doing is that it's logging rendered and it is rendering the value of count in here. And then it is also rendering a different component called second child. And then we are logging second render inside of it. So what do you expect the behavior of this component to be like? Since we are time limited, I won't give you time to think about it, But what this will do is basically every time the state and the parent component changes, all of its children are re-rendered. That's because React doesn't know where we are using the state inside of the components, and components might also have some implicit dependency to the state that React can't know about. So it's much more safer to re-render everything than try to optimize inside of this. So it's up to the developer to do the optimizations themselves, and we are going to have a look at it. So firstly, when I refresh this page, we can see rendered, which is basically the first component, and the second render, which is basically the second component. Now, when I click increment, it renders both the first child and then the second child as well. And as many times as I click increment, we can see that both of the components are being re-rendered. Now, how do I optimize this? Well, the most straightforward way is to memoize your second child component. Now, I guess if I have time, I might go into what memoization means and how we can implement our own memoization function. But I'll just say memoize child react.memo second child, and if we render the memoized child inside here instead of the original component that we had, and we check the console again, we'll see that second render only runs once, and whenever we are clicking increment again, it is not re-rendering the second child but only rendering the first one. So why is that? React.memo is basically a higher order component. So higher order component means that React.memo itself is a component which accepts a different component as its parameter, and it is returning a memoized version of that component. So again, I guess I won't go into details of memoization, what memoization means, but in this case, what that means is that based on the props which are being passed to second child, if the props remain the same, then it will always remain, I mean, it will always return the same version of the component. So in this case, since we aren't passing any props to memoized child, no props are being updated, hence no re-rendering occurs. However, if we pass in the dynamic prop that we have here into this component, I mean into the memoized version of the original component, and then we click on increment, we'll see that the second component starts re-rendering again, and that's because we are changing the value of count, which means that its props are changing, which means that it will cause the component to re-render. Now, if we replace this with a static value, for example, if we are just passing 1 to it, and if we refresh the page and try to click on increment a bunch of times, then that doesn't re-render the second component because it isn't really, I mean, the props aren't really changing. So yeah, that's how we can prevent re-renders. Now, I guess I can go into things like what does memoization actually mean, but Digvijay, I'm not sure if I have the time right now. Uh,
Oh, we're a little above schedule now, so I think we should just
yeah,
probably quickly wrap it up.
yeah, no worries. So, I was kind of aware that we were going to go over time anyways. So I have a small resources page here. You can look at what useref is. So useref helps you in preventing re-renders, not in the way that you expect. Basically, useref is for storing mutable values, and it doesn't cause further re-renders, but state changes cause re-renders again and again. Then you have memoization, which I briefly talked about, but you can go into more details by googling that. Like people way smarter than me have written articles about it. And then you have use callback and use memo. You can either check them out in the React talks or anywhere else as well. Yeah, one I guess fun fact that I would like to talk about here is basically that any memoized value that you have, it only React only holds one previous state for that. So it doesn't do any caching for you. It only helps you in prevent re-rendering. So you can't get, I mean, if you are expecting it to give you like a lot of performance improvement, then probably you need to look at the actual code that you've written. So yeah, I guess that's it about me. Thank you. You can find me on Twitter at the Writing Dev, or subscribe to my newsletter or blog at thewriting.dev. And I'm currently exploring new opportunities. So if you have one, feel free to reach out to me. So yeah, thank you.
Oh, here we are again. Hi again, Akash.
Hey,
That was uh, quite an interesting talk, very detailed, of course. And I think to sum it up, I can say that the key is the key to everything.
yeah, yeah,
Kind of. Anyway, so since we are a little overboard with time, we have a few questions, Akash, from the viewers. So we'll just try to wrap them up and answer them as quickly as we can.
yeah.
Um, in the form component example that you were sharing about remounting existing components, live coding wants to know if we can move the state to the parent component instead of keeping it in the form component. Wouldn't that be better? Akash, are you there? Folks, I think Akash is having some internet issues right now.
I might be back.
Yes, we can hear you.
Okay, yeah, sorry, my headphones died for some reason.
Oh, that's all right.
Okay, yeah. Please repeat the question if you can.
Sure, sure. So, live coding wants to know if we can move the state to the parent component instead of keeping it in the form component. Don't you think that will be better?
Yeah, definitely, but you still need to reset the state because if you have controlled input components inside, like if you have an input which is being controlled from a state component, then I mean, instead of generating a new state every time, you probably would find it easier to reset the key for that.
Right. Well, I hope that answers the question. There's another question from Rishi who wants to know what if he wants to handle multiple modals once the user enters personal details, clicks on next, and another modal opens with different inputs. What kind of flow would you prefer then?
I guess, yeah, that's a pretty complex question, and it will probably have a long answer. So, Rishi, feel free to reach out to me out of this, I guess.
Well, Rishi, you have the Twitter of Akash. You can find all the details to contact Akash in the description of this video down below. So you can always reach out to him and like, have a pretty detailed discussion about this. With that, Akash, obviously, I would love for you to stay back and help me close this event with all the other speakers and that we've had today. Let me see. I think Neeraj is here with us. There he is. And Nivedita, still looking for Nivedita. Oh, she's here too. Perfect. We are all here. So, guys, thank you so much for joining us today. Although a little short, but it was quite an informative session. Thanks to our speakers today, Nivedita and Akash. They shared some really cool insights into accessibility. Nivedita, just switch your video off. Or did that have? Oh, you're back. Okay.
Sorry, yeah.
Oh, that's all right. So, of course, Nivedita shared a lot of unique insight into accessibility and why it's important. And Akash led you down a path where you might need to now rethink a lot of things that you can do. I mean, there's a lot of new, unique ways of doing things. And of course, Neeraj, my partner for the day, was helped me manage this show and leave you guys with all the information that you needed to enjoy and get the best of out of this event. So a quick thank you to all of the viewers. Of course, I think there is one small question that was asked in the beginning of this event that I just wanted to put to all of you, since all of you are experts. I think we are just going to stick to a simple yes or no here and a simple one liner as to why you support that view. Because the question that's been asked, I think that's a topic for an entire meetup altogether. So, in the beginning, Omi Power asked, have we reached the limit of capabilities of React Native in the market now? And what do you think is the future going to be? So, anyone can just start and share your views quickly about this.
I'll say we haven't reached the limits of React Native per se. React Native Web is fairly new.
Mm,
Maybe along the line we see more homogeneity between websites and websites and applications. And this is very early in the whole community of cross-platform apps, and it is too early to cross any one of be it Flutter or
Hmm.
React.
Too early to give up on it, I think.
Yep.
Nivedita, what are your views on this?
I would like to hope that we have not reached the limits of React Native because, like, my livelihood kind of depends on it. But jokes apart, jokes apart, I think we've not reached the limits, and Facebook is working actively on it. So I don't really know a lot about like the limits question, but yeah, I don't think so.
Okay. And Akash, what would you say?
Yeah, I don't think that we'll be reaching the limits of any technology anytime soon.
Hmm. Okay, well, that's an interesting way to put it. Well, I guess we're all on a common consensus here that React Native is here to stay for quite a long time. I mean, me personally, I would like to have more opportunities to pick up a fight between React Native and Flutter whenever every chance I get. So I really hope React Native stays around for that. But anyway, I hope Omi that has answered your question. I think we'll probably do an entire meetup around this one particular topic and have people, share their views on what's what and what to expect next. But obviously, Nivedita, Akash, Neeraj, thank you so much, guys, for spending your time, your Saturday here with us and talking to all of our viewers who have joined in live. It was very informative, and I personally had a lot of fun. And I hope that all of our viewers have taken something back with them that they can learn, try out, and probably have this new motivation to, try out these unique ways that we have talked about today. A big thank you to all of our viewers for spending your Saturdays with us. Thank you so much for being here. And of course, this is not, we keep doing these often. This is not probably not the last meetup that we will do, and not by a long shot. Shouldn't even have said that. But of course, we have lots more coming in. We are talking about, we had a meetup about Web3. We have talked about NFTs. We host a lot of Twitter spaces. Uh, we have launched this new brand called Geekcast, where we are doing a lot of podcasts. Of course, you'll find my familiar voice there. And we're reaching out to people and talking with people about everything that's new and old in the technological world today. So, guys, make sure you follow us on Twitter, on Facebook, and everywhere else, on LinkedIn. Make sure you follow all of our speakers today. Reach out to them, talk to them about everything, any questions that you might have, or have discussions with them. So it's always good to network and get to know more people, and have a conversation with everybody. And well, if you follow us, you will be stay tuned of everything that's to come from the Geeky Ants network. And thank you so much for joining in. You have a great Saturday ahead. Thank you, guys.
Thank you.
Thanks
Till
everyone for joining. Have a great weekend.